Hi all, today we will continue studying propositional logic. We will focus today on truth tables for propositions. To complete a truth table, we need to identify the main operator and the order of operations. There is a simple formula to follow to calculate the number of lines for any given truth table. L equals 2 to the power of n. In the formula, L stands for the number of lines in a truth table, and N stands for the number of different simple propositions in the statement. By using the formula, we can construct the following table. In the first column, we have the number of different simple propositions. In the second column, we have the number of lines in its truth table. For a compound proposition with just one simple proposition and a logical operator, we have 2 lines in its truth table. For a compound proposition with 2 simple propositions, we have 4 lines in its corresponding truth table. For a compound proposition with 3 simple propositions, its truth table will have 8 lines, and so on. Once you know the number of lines of the truth table, begin with the leftmost column and divide the number of lines in half. Suppose we have a truth table with 4 lines. The first 2 lines under the P will contain T, that stands for true, and the last 2 lines will contain F, that stands for false. The next column, Q, will then alternate one T and one F. More generally, the leftmost column has the first half of the lines designated as T and the second half as F. The next column to the right then cuts this in half, again alternating T's and F's. This continues until the final column before the vertical bar has one T and one F alternating with each other. For example, let's read this truth table. First, we have the simple statements P and Q, and then we have the formula. The first column divides T's and F's, and the last column, the second column for Q, alternates T and then an F. The order of operations is the order of handling the logical operators within a proposition. It is a step-by-step method of generating a complete truth table. Since the main logical operator controls the final determination of the proposition's truth value, it will be the last step. Begin with the logical operators with less scope, and finish with the main logical operator. For example, let's use this formula. This is the truth table for the following proposition. Tilde, parenthesis P dot Q, end of parenthesis. Wedge Q. Begin with the logical operators with less scope and finish with the main logical operator. What is the order of operations for this example? Analyze this formula. The correct order of operations for this example is the following. Dot, because its scope it is just the P and Q inside the parentheses. Then tilde, because its scope is just the parentheses. And finally, the main logical operator is wedge, because its scope is the entire formula. To continue constructing this truth table, first we determine the truth values for each line under the dot. As you know, only the first line is true, because only in the first line both conjuncts are true. Then the other lines are false because in the other lines at least one of the conjuncts is false. The next step is the tilde. Its scope is the parenthesis that is determined by the conjunction. In this case, we just change the truth value of the conjunction. The result is that the first line is false under the tilde and the rest of the lines are true. The final step is the wedge. The two disjuncts of this disjunction are the Q and the negation, because the negation scope is the whole parenthesis. The first line is true because the Q is true in the first line. The second line is true because the negation is true in the second line. The same happens in the fourth line. The third line, of course, is true because both the negation and the Q are true in the third line. We should draw a box around the truth values of the main operator because it represents the entire compound proposition.